Okay. So that is how one can control. So one can control the error rate of the system by by thresholding it. And this is a graph that speaks of this is LLR threshold range. -5 to +5, you don't make a decision. -10 to +10, don't make a decision. -15 to +15, don't make a decision. -20 to +20, don't make a decision. The total LLR score. So when you do that, the error rates, which I believe are these two graphs over here, it keeps coming down and down and down. This one actually comes almost to 0 in terms of the error rates. We can control how, what mistakes it makes by simply saying don't make a decision in these hard cases, and say error rate is 0. And this is for the two graphs correspond to the error rate, and these two graphs correspond to the reject rate. So what happens is when you start making that threshold bigger and bigger in this range, your reject rate keeps going up and up. Here is almost going up to 40%. So if you reject 40% of the cases and don't make a decision, and you're only making a decision 60% of the cases, your error rate can go down to 0.
Well, that's the way it happens in real life too, with actual document examiners.
Yeah.
You'll get some guys who will never make a decision,
Yeah.
and their error rate's 0.
Right, exactly.
And then you got some other people who always either is black or white, and
Yeah.
many times they make the wrong
Exactly.
call.
So one can control this phenomenon by saying it falls in that range. Okay. And here is where, see, we made this data set available on our website. I think I sent email to some of you, probably not to all of you, saying you could check this out yourself. So what I wanted to do was a comparison of how does this computer do on these cases. And here again, the human examiner is presented with these same cases and is allowed to do yes, same writer, no different writer, or no decision. So human writer can do the same thing. So and we put this up I know any expert may not want to be subject to this test. You might not have enough time to do all these things, so you don't want to be held to your performance on this particular test. So my email said you can disguise yourself and log in as somebody, some pseudonym, and just let me know that you're a document examiner. That's all, and don't tell me who you are, and take the test. So that we can see how document examiners do on the same set, so we can compare it. We did that. Actually, we had 3 people do it. Emily, I think, was one of them, who boldly actually took the test, identifying herself. And of course, we don't name you by name. I just simply call you a document examiner. And so what we found was we had 3 document examiners, and we had the computer program, and then we had how many graduate students? 8 graduate students?
9.
9 graduate students. Computer science and engineering students. They also took this test. So we had 3 groups. Document examiners, only 3 of them. 9 lay people who are our graduate students. And then we had the computer program. On the same 824 data set. Now can you compare performance, how all of them do? And the issue here is that the computer program can be forced to always make a decision, or don't make decisions in certain cases. So what we have to compare, so we had to start with the document examiners. Document examiners rejected a few cases, saying I'm not going to make a decision on these cases, and so they had a certain rate of performance. So then, to be fair, we said, okay, we're going to control the threshold on the computer side too. It says don't make a decision in a certain range, so your rejection rate is approximately the same as document examiner's rate. And so in that head-to-head comparison between the 3 document examiners and the computer program, the document examiners did better. Okay, so they were the best. The 3 who carefully looked at these documents. So they came out as the best. The lay students, they came out worse than the computer program. Okay, so we are in between. So that's why you can concretely relate it to Moshe Kamp's result, that the document examiner's performance is significantly better than that of lay people. And where is the computer program? It's in between. All right, so we are able to establish it by this test. And of course, we had only 3 document examiners. So people can say, well, it's not a scientifically large enough sample. Those three, Emily must be the best the document examiners to get it right. We should get maybe more document examiners to do that. So I'd like some data, which is why I sent an email about which website these are. So if you go to that website, 2 documents appear at a time, and there is an option for you. And then did anyone do it at all here?
I tried. I found it very difficult to compare the documents on the screen.
On the screen?
Yeah.
Yeah, I guess document examiners don't want to go about it like that, because that's not how you do your work.
No, I couldn't do it like that. I did one. It was very easy and conclusive.
Yeah.
And I signed up as Gibson, by the way.
Yeah.
So,
Thank you. Appreciate that.
My computer I was having some trouble with, because anytime I would make a selection and move on to the next set, it wouldn't show the images, and I would have to close out and come back in and start over to get the next set of images. So I didn't get very far. I think I got through maybe 9 of them. But
one at a time you had to do?
yeah.
Open it and make a decision, and it would close itself?
Yeah. The first 3 I did fine, and then it wouldn't
Then we
show
should
me
check
the
that out. I
next
think there's
ones.
some problem. Maybe there's a problem
So
with
the
the
first
website.
3 were fine, and then after that, after every one, I would have to close it and come back in.
Yeah.
But my frustration is I kept wanting to enlarge it so I could look more closely at the details.
It wasn't there.
And so it took a long time to study it sufficiently enough that I thought I could move on, because I couldn't enlarge it and look at little details.
So
But it's
which is why otherwise
interesting.
Emily would have had a 0 error rate if she was able to.
Well, and I don't have a beautiful monitor either, but it was interesting though to do as far as I got.
Oh,
with
actually,
it.
Emily did have better quality images. You had the original data set. On the internet, we might have had a
Yeah,
lower
we did have
quality
the
image.
original.
Yeah, you had the original. So
Yeah,
you-
because we did it before it was on the internet. It was a while ago.
Yeah. So anyway, this is just a result from, if you ask the question how good the program is, I think you have a sense from these experiments as to where performance might lie. Yeah.
So I had been told that you were beta testing it around the nation. So have examiners used it in casework, and what were the results of those?
Well, casework-wise, the people who are most enthusiastic about it are the Canada Border Patrol, Mark Goodrow. Does anyone know him?
Oh, yeah.
Yeah, he's the one who's most enthusiastic about it. They have been using it on actual casework. So speak to Mark as to what he thinks of it. And the other group that has been enthusiastic about it is Netherlands police in The Hague. I forget.
Strasbourg.
Wim something? Wim the camp?
Oh,
Something like that.
Williams.
So they're very enthusiastic about it. The U.S. Secret Service, Emily is here to represent them.
Oh, it's
and,
Swiss.
they've had versions of the software in the past, and you had a head-to-head comparison with Fox, with the fish, right?
Yeah.
Fish, and of course the fish is used in a slightly different way than ours,
Yeah,
right?
it's very different.
Yeah. So we have, and a few others have been FBI. Gabe Watts worked with it, and at the Montreal ASQDE, he just tested it on ransom notes like the kind. He had people make up some ransom notes, and he reported in that ASQDE saying the program did 100%. We got everything right. But I thought that was not a real fair test. It's not quite. Look, there is an error rate as you saw,
Right.
and so one, depending on the size of the test. So that was Gabe Watts, and at the time Gabe Watts and maybe Jerry Richards were testing out earlier on. We still had some bugs in the program. In that if it encountered some complicated scenarios, it would just crash, it disappear from your screen. So that was kind of annoying to people that we had that happen, and so we've tried to fix a lot of these bugs since then.
In version 1, I didn't have one crash. It didn't crash over anything, so I was quite pleased to see that.
Yeah. And so there have been groups that have played with it, and you have a version at this point, and we'd love to hear from you if you have the time. I know you're all examiners and you have casework to do and other things to do rather than play around with software. But here's a tool for you to do your own tests on it and publish your own results too. You can say, you don't have to even contact me saying, okay, I did this work, this is how it came out, and ASQD might be interested in hearing about it as to how good it is in your experience and so on. So that's the only way we can gain acceptability. by the public, by making it available and having people participate. Like this test that we did with twins data, you could create your own small data set and run it yourself and see how it does. Yeah.
Is that set online? You're talking about those?
Yeah, the examples are online. There is a if you have internet access, we could actually show it to you.
Yeah,
You
it's a
actually do.
URL. You can just go through. We can write it and give it to you. Yeah, I guess.
Yeah.
Because we have access right now.
Yeah. Right off the top of my head, do you want to?
Cedar.buffalo.edu/nij/verifier.
Yeah. Want to try it?
I'm not sure actually.
Wow.
I emailed it to some
I
of
got
you.
that. Yes. Yes.
Yeah.
So
Because we did not have the email list of all of you attending, because many of you came on board at the very last moment. Whatever the list was about, 10 days ago, I think you got an email on that. Yeah.
Also, one more thing is that these error rates are of the hard decision and not of the interpretation. We don't have error rate on our interpretation as of now because we don't have document examiners giving us the data of the 9-point scale so that we can compare our interpretation with theirs. This is complete hard decision error rate. So we haven't yet.
Just the yes, no.
Yeah, just the yes no error rate, yes.
It's just a yes no error rate comparing. What would be nice for us to have? Maybe just doing it on the internet may not be the best idea because you're not going to have high quality images and issues. We could possibly send you a CD with these images and have you give your opinion. We got to make it easy so you don't have to spend too much time doing this. There are 824 cases, pairwise. So I know you're all very thorough, so it probably takes you at least half an hour to do one case, right? So I mean that's a lot of time invested. When Emily was an intern, I think Kathleen said, "Do it."
She got paid for it. That's
Okay.
the difference.
Yeah. Not much, but I
It's
got
good
paid
for
for
you.
it.
Not sure of the URL actually.
Go to, as I said, NIJ.
Is it
I found
The whole page.
Cedar Buffalo EDU NIJ programs, and then there's a list of demo programs. Tests.
Well, look at this list.
Oh, you just Googled for it.
Right here.
Is this it?
That's a paper.
Okay.
Test 2 or something.
What's the link?
Yeah, this.
If you have
Yes,
a
these are
set
the
of
ones
that,
actually.
yeah,
you
number,
actually found it.
test number 2 should be the
Test 2. Okay.
Test 2. Test 2 is twins data.
Yes.
the half page.
Yeah, it's
What's the UI?
test 2 /nij/test2/verifier2.php.
Oh, okay. Just
So
two
it's
here,
test
right?
2. Yeah, it should be correct.
Okay.
Yeah, here it asks you to put your name, email, organization address. If you want to use a pseudonym, remember what that pseudonym is and what that email you put in, so that if you want to stop, you do a few things, and then you want to come back again. It expects you to have the same username and email address, so you can continue where you left off. You you might not want to sit down and do 824 cases in one stretch. Like several sittings, you might want to do this. So which is why. So it doesn't really check for any. Maybe we need to have a legal email address. We might send you email on the performance.
Yes.
Right?
Yes.
Right now it's not required.
It's not required. Email is not required.
I don't think.
Okay, let's see. Let's skip that. I don't want to put anyone in a position that you have to reveal your identity. Yeah, there was no email address.
I put some dummy. Yeah.
Dummy email address. Okay, you took a dummy email address. Fine. But when you log in again, hopefully, at least it might go by username only, right? Yeah. Okay.
Yeah.
So this is the kind of images that come up, and you are asked to say same writer, different writer. Not sure. So that's a simple type of test to compare. We want to know how good our program is, which is why we needed this kind of a reality check, if you want to call it, right? Okay.
So I didn't see anything there where you designated if you were a document examiner or a layperson.
Which you know what I suggested to everyone: if you are a document examiner, give your pseudonym
Oh, okay.
docx, then something else. So I would know that you're a document examiner by the choice of your pseudonym. Okay, some random person coming in, wouldn't know that. Right?
So I used my real name.
Okay.
Would you necessarily know I'm a documents examiner? I mean, I didn't use the docx.
Yeah. Fine, since I know you, if it comes up as Panzilli, I know.
Can't you under organization put document examiner or something like that? That was one of the categories.
Yeah,
at the beginning.
correct.
Can do it.
Yeah. Okay, so there is another field you can enter.
Yeah, it says, I thought it said organization, right?
That's right.
You
Oh,
can put
see
document examiner.
The Cedar Tech webpage.
I don't know where it is.
Well, we're trying to get a few more data than 3 people. Right now we're only 3. It would be nice to get a few more. This will again, another value might be that we are establishing, once again, Moshe Kamp's result. The document examiners perform much better. And that's been, I think, a valuable thing for you all in a courtroom situation to establish the validity of your field or the scientific basis for your field and so on. So that will be one more data point for that. Okay, where were we? Well, somehow we jumped to twins. I guess we did all of this.
And
Full
view,
screen?
yeah, view full screen.
Full screen.
Ah, beautiful.
Slideshow.
Ah,
Victim of technology.
okay. On to the Tippett plot. We get into this this idea of Tippett plot that Paint Flakes people suggested it to us, and I found out about it almost accidentally. I went to a forensics meeting in Istanbul. Did anyone go to that European forensic meeting? There's an organization called European Forensic Community, something like that.
I was
Right?
supposed to go, but I couldn't make it.
Yeah, and I was attending sessions, and I went to a speaker verification session where they were talking about this problem. So all of these problems, all the forensic domains are similar, right? You're trying to identify the person. So they are also facing the same issue, and they were putting up these plots called Tippett plots in these speaker ID problems, speaker verification problem. I said, wow, that's a neat concept. Maybe the QD community can use this concept. And so we brought that back here, and made the first use of this Tippett plot in the QD arena, where we computed the Tippett plot for twins, non-twins. All right, let's see. This is the log likelihood ratio values here, which go from 0 to 300, 0 to minus 300. And this is a proportion of test cases where the LLR value exceeds that particular LLR value. Okay. If you recall a little bit of probability theory, the PDFs look like this. The bell-shaped curves are PDFs. Then there are what are called as CDFs, cumulative density function. They look like that. They kind of go like this, and then they go like this. You see, and it says what is all the probability of all the values up to that point, and it goes up to 1 like that. It starts from 0 and goes up to 1. Right? This is actually the reverse of the CDF, that same function placed like that, and that can be computed by the frequency of the values of LLRs you get by observing a lot of cases. And so these plots come around here. Now let's see, red ones here are what non-twins, and blue ones are twins. Okay, so the red ones, the outer side curves, are non-twins, and the solid line is the same writer, and the broken line is the different writer. Right? Let's see, this is the same writer here, and this is a different writer. This is a different writer. Okay, same writer. Okay, so these two are for different writers, and these two for the same writer. When we are talking about twins, there are different twins we're talking about. The pair we are testing are just pair of twins. They're not the same person, but different individuals. So these curves for the twins turns out to be closer to each other for the same writer and different writer. Then for non-twins, it's further apart, which kind of indicates that the twins are harder. So it's kind of quantifying, are twins really similar to each other? And it's kind of quantifying here. And yes, twins do write more often write similar to each other than not, and it kind of quantifies that. And so now, if you get any LLR value, and we go into this particular graph here, and what does this tell us? If we find that the LLR value is, let's say, some number, say 0, okay? If it turns out to be 0, then we have a reading over here. It says 25% of the cases for different writers are larger than this value, right? So that's the interpretation of that. And 75% of the cases are. So when you get a 0 reading, that's what it means. That's the interpretation. So this is the kind of graph we have to use to map from the LLR value to what proportion of the cases, the percentile, the 95 percentile. To be able to get that, you need to have created these kinds of plots, which is actually which is based on observing on a large number of cases the LLR value when they came from the same writer, when they were not from the same writer, how frequently they occurred, and you convert the distributions into this kind of a plot, keep it ready, and in the future, when you have a certain reading, you go over here, get the reading, and then that will tell you when they're from the same writer, when they're from a different writer. You can read them off, and that's how you get the percentages. So that's the use of the Tippett plot, is of converting the log likelihood ratio score into a strength of evidence, which is the percentile score. So this is kind of this graph is a little bit involved, but it's not a too complicated a concept to understand in terms of the distributions that would occur. This is the kind of work that is needed for any forensic system, for that matter. Say I have an AFIS that gives me a certain score when they are from the same finger, and a certain score when they're not from the same finger, and you want to convert that into because AFIS will give out some number. It will give well, I don't know, Bozorta, what are the kind of scores we get? 30?
300 or 400 also.
Yeah, at least the score is 300. The AFIS examiner actually knows these things, what it means to say a 300 or say very high or 25 is too low. The AFIS examiner knows it. But to be able to convert it into a jury's terminology, you've got to be able to say, what does that mean? And you will have to say that is very strong in that when they're from the same score, only 5% of the cases were larger than 300. So that is a more interpretable type of thing. So the same kind of thing, because our system is putting out LLR values, we need to convert it into this kind of a statement. And so that is how we get it. So if you didn't get what the Tippett plot is, still, that's what the basis of it is. So when it's able to give you that kind of statement, it is referring back the frequency of these things. Because it would all be nice for you to compute your own Tippett plots and so on, and tailor it to your own data set. Maybe that's something in the future. You would create your own strength of evidence. So, Linton Mohammed can say that of all the cases I've seen, this is stronger than those or weaker than those. That maybe that has more value than cases that our system has seen so far. So it might be useful to put a machine learning approach to this problem. So Tippett was an English forensic examiner. I think he's well and alive. He's not like a dead man or something. He's might be known to some people attending international meetings and so on. Okay. Writer identification. This is okay. While we were just coming in, I think Randy was asking me, what's the difference between 1 to n verification and 1 to n identification? Right? Was that the question? Yeah. So we saw 1 to n verification. I think the question was raised by Karen Runyon about can we match against several known samples And we actually showed you how it can be done. You have several nodes and one question, the system is able to give you a score. Identification is, I don't know if you all encountered this problem much, but let's say it was the John Benet Ramsey case, and there might have been 5. I mean, it is an unsolved problem. Our computer program would not be able to solve it beyond any of the document examiners that were involved. It's interesting. I actually got a call from the National Enquirer around that time, asking, can your program say, and they're going to splash it all over. Computer program says, who did it? I said, no, I'm not going to get into this. Because a human examiner is going to be better than what this can do. It will give a strong opinion in some way or the other. So this is identification. I have 5 suspects, and then I have this question: whose is it closest to? The way this system is working is a fairly obvious manner, which is it gives you the verification score against each person. That's all it does. The way it's computing the LLRs, and it simply rank orders. So you could do it manually yourself, saying run against this, run against that, but you can set it up automatically, and it is simply matching against several documents and gives you all their scores, and it sorts it for you and says which one was it closest to among all of these. It says, okay, that is the right where it becomes. Okay. Well, there are some fine details here. I think we already did this word recognition. I'll skip this. Word similarities, we saw this already in action, so there's no point in the PowerPoint. Document properties, we saw. Document line structure, we saw. Letter formations, we saw. Okay, there are other small things that the computer program can do for you here. Sometimes you really don't want all opinions at all from the computer program, and you just want it as a tool to do a few things so you can make a better presentation of your work. Perhaps something like this, which is a contour display, right? Maybe Chen can show it in the program. Right, you want to do that? Okay, fine. Let's do it really interactively. Still after lunch right now.
I changed that.
This you can do on your own computer. So it's an option under the view menu.
Try to remove the text. Let me open again. Yeah, here the right lines are those exterior contour, and you can see the blue lines indicate the interior contours. So this.
Okay. So the way you get to it is by the view menu.
Yeah.
View menu, and there is a contour display.
Contour display.
So if that is of any value to display. This is just an intermediate step. The program happens to do this kind of computation to compute the features of the shapes of the letters and words. So we just are displaying something, some intermediate step along the way. Okay, we get to this next topic. Let me introduce it, and Harish will present this part on the actual software itself. The basic idea is you would like to search a document image or document images for a certain query. So let's say we had this as the one of the documents, maybe question or known, and we select a particular region here, saying we're trying to look for that, and that becomes your query image. You first use the search option over here, and that will give you some choices, which allows you to select what you're looking for here, and it displays it as your query. So in this case, the query happens to be an image, and then you specify as to where you are searching for. Maybe you're searching in this document, and in this document it runs through everything here. It says, where do I find the shape, and it picks that up. It picks several of them up and then displays each of them, and you can say highlight where it is, and it highlights a particular image for you. So this is just an option to search for something that you are looking for in the known documents. And this is searching documents by text query. Okay, we'll go over this again. This is just my slides on it. So here is a document here, and then I will have a regular query. This is like a little Google window over here. We type in what we are looking for. You type in bean, B-E-E-N, and it runs through this image, and it's not using the truthing in this case. Of course, truthing becomes trivial. If you had already truthed it as bean, it's just matching it and pulling it up. Here it is actually not a truthed image, and it takes that and runs through all the words and finds the closest match and says that's the top choice, second, third, fourth, etc. And you can say, where did you find it? So it could go and find it. Yeah.
If you have more than one question document or more than one known, and you want to do a text query, do you have to do it document by document, or after they're entered, does it pull up all of them?
That's not necessary. That's the main advantage of the search. What you do first is take a whole database and process it in one go by a batch processing. It's all ready for processing now. And you click on search, which I'll show that, and then you can type in bean, retrieve all documents which have this word. So it takes a whole bunch of database.
Yeah, third process.
Actually, this indicates here already.
Yeah.
You're running through, in this case, they happen to be on the same document, but document ID. So which document did you find that in? So it will tell you.
Okay.
It will tell you which document it is in. So
There's
we can
a radio button in the top.
Yeah, radio button. Okay. This one here.
Current system.
Where do you want me to search? So this is my query, and where do you want me to search? In the current document you have open, or if you have two documents open, the known and question, the other document, or all preprocessed documents. So you can select that, and it will run through all of them. Of course, it gets slow when you're running through many of these images, but so we don't want to select too many in our demonstration as such. But that's the idea. So there are, summarizing this, there are 3 search modalities in Cedar Fox. One is you can type in the text here. This is text word. Retrieval is the word images. You typed in *TED, and it pulled up all these in which document it is in. And in this case, the query is not a text, but I'm looking for this particular shape, this pattern of writing here, and it pulls up that pattern of writing there. And the last one is retrieval is words, that is text, and I specify a particular word, and I want to ask, what is this? What is this particular thing that's been written? And I think we need a lexicon for this, right? So you say, this is a word among these possibilities, and which one is it? Or give me a ranked list, what the shape is, what it could be among this set of possibilities. So it ranks them, saying what the word. So the output here are the string of several words in some ranked order. That's what that is. So there are 3 types of search. This is text is the input, image is the output, image is the input, image is the output, or image is the input and text is the output. So there are all these possibilities. Of course, the 4th possibility is text is the input, text is the output. That is the standard Google search, So you type in something and you'd like to have the text in some document, it's there. So Google does that for us. But these are the types of things that a document examiner might be interested in, which all involve images, which is actually the handwriting. All right, so I need to stop here, and leave it to Harish to show the search modality.
This can be
Okay, this can be. Okay.
You can follow.
Yeah, you can follow along now
Here.
on your own system. I think that's the best use of our time here.
So let's just have Cedar Fox open with no documents. I think what we will first do is take a whole bunch of documents in one batch mode and process it. And then we will search for something in all these documents and see which document has that particular pattern or text. So to process all the documents in a batch mode, under File, there is an option called Batch Processing. And then you have Index Images. So you can click on Index Images. So it will ask you to select the images which you want to be a part of the database. All these documents that we have here are already truth. So I'll choose PNG images. Yes, on all your machines you will have PNG images. You choose PNG and you have a list of a lot of files here. You can just choose a bunch of files. Just click on maybe this one file, press shift and click on this last file. It will select both these two columns. So just click on this file here, whichever you have over there in your list.
That's right.
Then press shift and press whichever the last file which you want to select. Selects a whole bunch of files. So we have 12 files selected here. And we click on open. So what it will do here is it will take each file, do line and word segmentation on it, and just prepare it and make it into a Fox file. So this process, 12 files we have taken, it will take probably 20-30 seconds for it to finish up processing on all the files. Depending on the speed of the machine, it may take different times on these machines. We'll wait for it to finish. And I think currently there's a limit set on Cedar Fox as the number of files at a time which you can give. I think it's about 50. Yeah, if you give more than 50, it will take too much memory, I guess. So 50 is the limit. So you can do it in batches of 50 if you have too many files. So you should get a message after it's all done saying pre-processed, how many ever files you selected. So click on OK if you already have got the message.
Release that. Click the first one. Then press shift. Click the last one.
So what has happened is we have created 12 Fox files now. We might already have some Fox files before in our directory, so and then we can go ahead and search. Everybody processed the Fox files, I suppose. You can now in this menu you can click on search, and under that there is an option text search. So we'll first look at giving a text as a query, and you can choose a second option, use image. So there's a difference between these two. The text search using image is what we have all these processed files and they have not been word truthed. So the text to word truth is like what he was talking about. This is a Google pull-up, just a string match. The first option is just a string matching. The second option is where there has been no truth provided for any document. They are raw document, just processed, that's it. And so you can click on text search use image, and you must get this dialog box where you can type in the query. Maybe I'll type in some word. Cedar letter has this word. Queensberry. Okay. THE is too common. It will pull up too many things. So I just you can type in whatever. I think there's So it already has a radio button here. Pre-processed documents. Here you can click on go. it'll ask you to select which documents you want to search in. So you can select a bunch of Fox files. Again, click on one file here and click on press shift and then click on select a bunch of files that you want to search in, and then click open.
Use image. Yes.
So what it does, it goes through every document, every word in every document, and tries to see if this word can be the word Queensberry. And then it pulls up and rank orders every single word in terms of its similarity to what this can represent. So the way it does this is it takes this particular word image, which is Queensberry here, every single word image, and tries to chop this sequence of this image into how many ever characters, such that the first character is Q, second character is U, and so on. And there's a character confidence with each of those matches. So the image that corresponds to the maximum confidence or the lowest distance between them will be pulled as a top choice. And it also gives us gives you which document this was found. So this was found in 2A, 2AU, 2B, 2BU, and so on. I guess all documents had this. All documents uppercase. The upper part of the document is where the Queensberry is there. So all the U have been pulled up. And when you say highlight word, it will actually open that document and highlight the word in that document. So you can click on some highlight word. So it will just open that document and it was found here. So that's the search by text option. And then next thing we can try is search by image. For that we can close this document. For search by image, we need to select an image first to search for. I'm looking for this particular pattern. So let's open a document first. Click on Q. You can select any file. I'll just select this file, 001BL, Fox file. So here, there is an option under search. Again, text. You go to image search or word spotting. This is under search. You can click on image word spotting, which is under search. And then if you come down to the document, you see a cursor for you to select a box. Maybe we'll select D here. So click once on the left corner of above the T. You can leave your mouse and drag the box to complete the D. And then click it once more. Once you have enclosed the complete word. So the moment you click it, let me close this dialog box here. So this is the word that we have selected, and then we can say search in. Select pre-processed documents. So look in all the other documents, wherever this pattern occurs. So pre-processed documents, select go. And then again you can choose. I will leave out the document where I selected. Or maybe I can include it also. It will definitely pull up itself as the top choice. Select the first document, shift and select the last one. Then click open. So it pulls up again all the documents which contain D. I guess there'll be a lot of them. Each document contains many.
There's two different documents. Yeah.
So that's search by
This is,
image.
lower half of this.
I think that's about it for search. Mainly for searching in the database, entering the query as text and query as image. Yeah, go on. Question, yeah.
So if you go through and identify every single word, then you just do the word search.
If you already have the word truth,
Yeah.
or then you can just go for search, text, use word truth.
Okay.
And then yeah, that will be a definite match. So it will have no errors because you have typed in the word, you're searching for this, just a string match, and if it's there, pull up the image. Yeah.
We're going to show a little bit of the Cedar Fox installation. You all have the CD with you, and once you put it into your drive, this is the sequence we go through. There are two different options here. One was a standard installation, and the other one was a special one.
Yes.
Okay, I'll let Chen and Harish talk about that.
Yeah, so after you put CD into CD room, this will start automatically. Just one thing I want to point out is this. So this code is by default choose. If you did nothing, it will install. This will install every basic component. Only thing missing is here. It's mentioned without the video files. The video files is in the help user menu. There we have some functionality in video available. So you go through every step by step in this video, but not all those functionality. And we are still updating those videos. So since the video file is much bigger, probably without that 30 meg is enough, but the video file itself is about 150 megabytes. So normally we don't install that, but if you want,
so
you can
if you
choose.
do want the video help manual, that's what you have to do.
Yeah, you choose the custom, and then here it asks you. You can just check this. Yeah, it's 125. This just require more space. That's it.
Right now we are installing the video.
Yeah.
Okay, that's going to take some time.
Yeah. And what's the difference between custom and typical?
Only difference one is with video files, the other is without.
This is the user manual part of this system. There is a help user manual in this version that you have already installed on your laptops here. We're going to go through the user manual. But if you, within the user manual, there is a video help. The sense it's not just a static, you read this manual and do it. It actually shows you what you have to do using some kind of a video interface. So if you want that type of manual, so just a user manual thing, if you're comfortable with what you have learned so far and you don't really need that. But if you want to just hand it to somebody and says, okay, learn using it, and maybe the video will help them.
And for the video files, you select typical rather than custom?
No.
Other way around.
Other way around.
Yeah.
Mhm.
Okay.
Typical doesn't have video,
All right.
where custom does.
If you just happen to click next, and so on, it will go with the typical setup without the videos.
Okay.
Yeah, you have to interfere and change it to custom if you want the videos.
Okay.
Basically, it captures the sequence of operations you are doing, like you're moving things around, clicking this and that, and so on. It shows that in a running form.
How big are most hard drives on my computer? 60 gigabytes. 60.
between 80 to 160.
We're taking 1% of the disk space.
Okay. To open the user menu, just go.
Okay,
help.
so you can also follow along here to use the user manual.
Choose the user menu.
Show the other options also in the user. Okay, we can get back to it afterwards.
Okay.
Yeah.
Yeah, this is the user menu. It's just like the typical Windows help. You can follow the content here, or try to search some keywords here. So, for example, yeah, this is shown great. This is screenshot of each step. Let me see where's the video. Yeah, for example here. Yeah. This is one just Harish just showed search by image, or search from text to image.
I don't know if anyone is able to run that video on their machines. Can you just show how you do that again?
Probably.
It's not installed in this one.
Right.
Yeah. Oh, it's not installed. Okay.
The typical installation.
Right.
So basically, anything like this, click here to see demo. That means it has a video file associated.
Yours has those words, but when you click on it, it just gets black. Can you click one just to show what it's like, or are you not planning on doing that?
Yeah. It automatically load the Windows Media Player inside this, and
it is doing all that automatically. He's not doing anything.
Yeah.
It's just going about automatically.
This is the video.
There is also, along with the video, there's also the audio part which walks you through the particular tool. So if you have your speakers on and the video files, it will play through that, yeah. So it tries to go through what you need to do that for that particular option.
Is the audio file loaded only with the video file, or is it in all of the help without the video?
It's together.
Video and audio together?
Yes.
Thank you.
Are we not hear anything?
Here I guess the speakers are yeah.
Okay.
Speakers aren't connected?
I think so.
Might work on one of ours.
We're not even being able to get video up.
Huh?
We're not even being able to pull the video up.
They didn't load the machines with the video.
Your machines don't have the video option. When it was installed, we should have gone through the custom installation.
Yeah.
Who did the audio?
No.
Who did the audio?
Some others too.
Some other student who.
Obviously.
Unknown source.
Okay.
Can you show the search option there?
Sure. Basically, this organized according to the manual. So, like features, search, tools. Is search text to text. Is text to image. Is word sorting is image to image.
Question, can you print out each one of the chapters individually?
Print out.
Like the chapter, print that particular chapter out.
I think you can print out each page, but I'm not sure.
So you have to go page by page. Then. That's my exact question.
Right? Yeah. I have never tried that.
We have a print method. That's a good question about other things too. On any screenshot, for example, contour display, and you say, I would like to print it out, there's a print option there, right?
Yeah.
You want to show that on the system? and also the spreadsheet.
Oh, okay.
Supposing you like this one and you wanted a printout of this.
Absolutely, yeah.
There is a print option there. You can send that to the printer.
Can you click on print preview just so you
yeah.
see it?
Okay.
Probably too big.
So it'll just print what's on the screen.
No, it's I think it's beyond one page.
It's beyond one page here. So
The image is too big. I think, did you change it?
you can reduce the scale and print it. The preview will be better, yeah.
It looks like it does each heading.
Yeah.
That's
You
not
print
me.
it.
I think we should. This only looks better in 100%. So probably it will print several pages, I think.
For the scoreboard, though, we have a copy to spreadsheet option.
Want to show that one?
Here.
The contents of the whole page with all the numbers, and it's all dumped to a Excel file which you can specify. That's to keep record or save a particular case kind of thing. Yeah. The next version we will also be having the database functionality, so you can actually save a casework into a database. Currently, you can save only one particular document type, not a particular pair as a case. Database functionality will include saving it as a case. Yeah.
A few of the miscellaneous functions, such as protractor.
The protractor.
Okay.
Yeah, this also you can follow along. There are a few options other on the toolbars, which I can go through one by one. So we can first open a document. You can click on Q or K. Just select an existing file, and here one option here which you can see here is a grid-like thing. This is if you want to make some measurements of some sort, so you can place a grid. And the second click will give you a final grid. And let me enlarge this scale to 100%. So this is if you want to take some measurements. The software also has inbuilt measurement tool. Specifically, it gives you exactly how many inches was or how many inches was this word's width, and so on. So that can be obtained in tools. So we may want to first scale up the document to maybe 100%, and then go to tools. There's a ruler protractor option, the last option in the tools. You can click on that, and you get a small dialog box which you can move around. I'll just put it here. But there are two things. You can measure distances. You can also measure angles. So I'll first show the ruler. So you can say add ruler. Click on add ruler, and then maybe we'll measure the distance or the width of T, So you can click on the first point of the ruler. Okay. No. Okay, I mentioned something else. Let me clear this off. You say add ruler, you move your mouse to your image, you click on a particular point. And then you click again on the next point where you want to ruler to end. And this dialog box gives you the distance. It's 0.23 and it's in inches. And you can also use it to measure angles. I'll choose maybe, let's see.
Let's show centimeters, hopefully it's making good conversion there. Okay.
So here it says the origin and destination where you clicked. And next I'll just measure some angle. Maybe the slant of the B in the beam. So I first click on add protractor in this dialog box. So a new line is added here. So for the angle, you need to make 3 clicks. First is the horizontal line. So you click on some point at the beginning. Maybe click on then somewhere here. So that's the first line. The second line we will have it at the stroke of where the B ends. So this is the angle here. And that's 81 degrees, which is showed here. So again, this you can keep adding rulers and protractors to the whole document. You can take a whole bunch of measurements. And along with this, in this dialog box itself, you have the grid. You can show the grid. You can have a final grid. And also you can set the resolution here. This whole conversion from distance to inches is based on the resolution of the document. So by default it's 300. So if there is a higher resolution image, then you need to specify what resolution the image is.
That's something you may want to show, the 600 dpi, how that part works.
Yeah. Okay.
View. There are no different to view it.
Let's go over the other functionalities here. Then we have define ROI, region of interest. So if there is a page of document with handwriting only in some region, and others are not are unimportant regions. So what you can do is click on. So there are 2 different kinds of ways you can select the ROI. One is a rectangular box. This allows, if you click on ROI, again you have a cross that comes on the screen, and you can just select as you selected for the word spotting. So you click once, you start drawing a rectangle, you click again. So when you click again at the end of the word, it will ask you for a file name to which you want to save this region of interest as. By default, it will have a name. So underscore ROI, and you can click on save. So that image is ready, and we can open that image and see. TIFF file, we just save this as an image, and this is the file. So it's over here. So you can create small regions of documents using this functionality. And also you can use the other option, which is defining the ROI using a polygon, because some areas might be difficult to define with rectangle. So you can use the other one, where if you select this, you can select a polygon by just clicking. So you go click, click, click. And then you click on the define otherwise polygon again. And now that becomes another region of interest. You can save this.
That becomes particularly useful when you have a complex document and you don't want to put that whole thing through the system, but only the handwriting portion out of a document, an office document, let's say, with a lot of printing on it and some handwriting on top of it. You could capture that using the ROI method, and that section itself becomes your new document.
Yeah. So this is the two functionalities here on ROI. I think what else do you?
The image resolution 600 to 300.
Okay. So if you have a document which is higher than 300 dpi, currently we have one example of a document, and you also might have it in your sample images folder. Under if you click on Q and PNG images, and if you scroll,
Probably it's not in this folder.
on this folder.
No, it's not in this
Okay,
folder.
high resolution image is not
Yeah,
there.
because it's too big. We
Too big.
took it
Okay.
out.
All right. We don't have a high resolution image. So, but what would we do with it? You can just show.
Yeah. So what happens is if you have a higher resolution image, let me just open one other file. All the processing of Cedar Fox, which is the line and the word segmentation, is all controlled at 300 dpi. So if you have a bigger resolution, it automatically downsamples it to 300 dpi to process it. However, you can view the image still at 600 dpi. For viewing purpose, it will be at 600 dpi, but the internal processing of the document, the algorithms are tuned to work at 300 dpi, so it will automatically downsample it to 300 dpi and do the processing. And you can toggle between 600 and 300 dpi with this option here. So which is there is a small resolution toggle here that will get enabled if you have a 600 dpi document open. And so it says here the tooltip resolution toggle, so it toggles between higher and lower resolutions.
Do you get better search results when you do it that way? On 600 versus 300?
We were just talking about it earlier on. 600 dpi is more satisfactory to view it visually. You would miss a few things if you only had a 300 dots per inch image. And Randy was telling me that he scanned some things at 1200 dots per inch signatures. But when you go from 300 to 600, it's not twice the storage. It's more like 9 times the storage or something, So it's both directions, So you really don't want to have such huge files unless you absolutely need to. So if you happen to have scanned the whole thing at 600 dots per inch and still want to use the system is able to handle it. If you really scanned it as 1200 dots per inch, the entire document, you'll have to downsample it somehow and then bring it over here. 600 is okay. So, but we thought it's useful to have both. When you're viewing it visually, we want to look at it 600 dots per inch. And then for the processing part, it's working only at 300 dots per inch. If we really had algorithms working at 600 dots per inch, it would be that much slower, the whole process, and we don't need it for the kinds of things we're doing, matching shapes and things like that. You don't need such high resolution for that purpose.
Have you guys thought about increasing the from 1-bit processing to like 8-bit processing, to do the shades of gray?
Well, as I was just saying, for many of the things we are doing in terms of the nature of the writing, you really don't get much value.
Well, but to increase so you could do more discriminatory type things.
Yeah, there would be possibly some value in it, but the amount of value contained in those 8-bit images is not significant enough.
Okay.
So which is why we are using the single bit in terms of the shape, how is it going, as opposed to examining the edges of the stroke, how soft they become, the There might be some value in it, but we're ignoring that incremental value you might get out of it.
Current grayscale is 0 to 255. So in terms of it's a byte there, so it's there.
8 times the storage. His question was processing it at 8 bits, right?
Right.
Yeah.
So it's not the black and white. So you're talking shades of gray. So you're talking pen pressure,
whole
you're
processing
talking
itself
stroke
on
direction,
yeah.
those sorts of things.
Right. Yeah. So the present system does not do that, which I don't think is a serious drawback. Which is how for example, the postal systems, they also work like that. The older postal systems, interestingly, in the US, all the postal sorting machines, they were scanning at 212 dots per inch. Of course, it was all based on processing power, and so they have to process like a couple of million pieces at every center per night. So you don't want excess data processing unless it's absolutely needed. So it used to be 212 because the American machines were all German, Siemens machines. They were in centimeters per inch. So it ended up 212 dots. I should say dots per centimeter, dots per inch. So that's why they were all 212. And the U.S. Postal Service, when we were working with them on some of these image issues, we decided to go from 212 to a higher resolution. So we had to change all the cameras and processing and so on. So 300 was kind of established by the Postal Service for reading postal addresses off of envelopes. Anything larger was not worthwhile for the machines. They weren't doing anything higher. But the human visual system is so powerful. Obviously, we can easily tell the 600 dots per inch, 300 dots per inch, and Randy can tell. I guess he's magnifying them and so on. So
if I need to do a display showing striations or something, I'll go to 12.
Yeah.
I do the same.
Right? You do also at 1200?
Yeah, I go up to 2400 on my big scanner
Really?
on a signature.
Yeah, on a signature.
Yeah, it's the same as Randy. I rarely do it, but if there's something very specific in a detail I really need to show, I'll scan at 2400.
The fingerprint people, they normally do, I believe, around 500 dots per inch for most of the AFIS type of work. But if they want to do look at the pores, the ridges, they do go up to 1000 dots per inch. But I haven't heard much more than that is needed.
For everyday cases, you're right. The files, the storage and the processing is just so enormous, it isn't worth it.
Yeah, you would need faster processors. We don't have special purpose processors.
Well, you couldn't
for
do
that.
a page. I'm doing a word or maybe 2 words at the max at that, and I still got an enormous file.
Right.
So.
Okay. There are a number of image processing options we didn't go over, rule line and things like that. Maybe we'll let Chen do that part, under rule line removal and so on.
Yeah. So let's see. Yeah, we have one sample image, so you should have it also. Just open QRT and select PNG. This file name is rule line test. Open. It's just an example of rule line image. Again, the first step is still the binarization, so let's just try the first binarization. Then this rule line removal, you can try any of them. So it's remove most of the lines, but still remain many of the dots here. And you can try different algorithms to see which is best, give you the best results. The third one has this user control here, but it also takes longer time. the most right side is remove less lines. If you drop to the left side to remove more lines here.
Push it all the way to the left.
Oh. It's already done.
Most of the time, the first option is generally pretty good in itself, and it's the fastest. The remove underline option. In specific cases where the rule lines are really skewed, the third option will work better. But in most general cases, the first option itself is good enough, and it's the fastest.
So is the remove underline actually de-skewing it as well? I thought I saw that. But I didn't.
Yeah, I saw it skew when I straightened out when I did it.
The half line removal will do the skew one. The remove underline will not. Yeah.
Okay.
The half line is similar to the document properties one, when we had all the lines lining up in those images. So it will detect the skew and also correct the skew.
But still, in this case, many dots remain. This may affect those. So the next version, if we have the eraser, it's better to remove those small dots.
And of course, in the larger scheme of things, as I said, when you have lots of G's and lots of things, maybe it doesn't matter that much. But if that's the only information you have, you're matching G's, not going to do well. Which is why maybe you should have an eraser function to manually remove that.
So for now, that's just something that we're going to have to adapt to when we're looking at it.
Right. Yeah. Actually, one of the small projects going on with, currently is handling not just under the rule lines that are on the page, but when the actual writing is running into each other, right? The descender of a G interferes with an ascender of an H. Right, the two of them are totally running into each other. What do you do now? The line segmentation is currently just cutting through, calling this part belongs to this word here, this part belongs to that word. The true understanding of what belongs where is to actually follow the strokes and eventually really understand what this writing is about. That's where the human knowledge comes into play. So this is what the writing is. So how do you code that into image processing? Image processing is tied up with language processing because you are trying to follow this. So we're at least trying to do one thing is the descender of a G is a smooth flowing stroke. So we can say, at least can you follow the gradients of that stroke? So I can tell that's a smooth stroke, even though it might be a person who doesn't know English, might be able to say that seems to be a smooth curve here, smooth curve. So that's the algorithm we're implementing right now. At the present time, we're kind of doing some hard cuts. So that's where we are on that. Right. So I guess we have covered almost all of the functionality except for that one section, which is a signature verification. Okay. Okay. So. Okay, were there any other questions before we start the signature?
Just one point. I'm coming back to the comparison we did between Pam's and Randy's writings. When we did the similarities and differences, they were weighed equally. So basically, you added them up plus minus, then you got like almost a 0 score, which is the conclusive. But in a document examination, we tend to give more weight to a dissimilarity rather than a similarity. Because when we look at it visually, lots of stuff jump out to us immediately. That's a difference. That's a difference. That's a difference. But the computer wasn't looking at it the same way. Because if you could build something into it that would weigh the dissimilarities more than the similarities, if that would make sense, to get a more accurate result.
Well, see, again, the whole design is based on no person writes the same way twice, and every person writes differently. That's the underlying principle here. So we kind of look at what is the variation of that one person, statistically speaking. So we take that into account. And then what is the similarity between two different people when they write? So that is the underlying principle we are going by. And so whenever we look at two things, that we take the difference between the two, and then we say, how likely it is that same person's variation, how likely it is two different people's. That's how we compute it. So in a sense, we are not biasing one way or the other. We're saying, and you're saying maybe we should bias it one way, and wait.
I think as document examiners, we bias it one way. The difference is, let's say, worth more than a similarity.
Fundamental difference.
One fundamental,
I suspect that's why your computer system is not as bad as lay people, but not as good as document examiners. And I wonder if you just ran a test where you changed those and weighed those differences to some degree more, just to test whether that improved your system. Because I suspect you're kind of doing it's 50-50, which lands you in that right between lay people skill and document examiners.
The current system, as it stands, the error rate has two kinds of error rates. How many of same writer cases do you report as different? How many of different do you report as same? They are currently about the same right now, which means that the way suppose we were to report way more dissimilarities, it's possible that we take two samples of writing of the same person, and there's some very little dissimilarities, and you weigh them more, it can shift to the other side, saying that they are actually different writings. So one type of error will go up, and the other will come down. Net effect being the total error rate still remains the same.
It isn't so much, it's probably more complex than that, really, because when we look at them, the combination of similarities together is additive towards a identification. But when you're looking at differences, first of all, you have to weight those differences. A difference just isn't a difference. When you look at differences, when you're looking at similarities, you always weight them into the same bunch. They got the same weight as, for the most part. But with differences, you don't know offhand when you look at a difference if it is an accident, if it is disguise, if it is another writer. You don't know what the cause of that is, and what you're looking for is consistency in those differences throughout the writing. And the more consistency you find within those differences, the more indicative of another writer it is. And those are usually in the subtle details, not the gross ones.
I think we have a valid point here. The current system is working on total averages over all people's writing. And we need to focus on specific features, specific types of writing that we have.
I think something like that would be about version 6.5.
We expect that this project is going to be running for another couple of years. So we hope to have a lot of these ideas incorporated.
Even, we're talking about this, but even document examiners have a hard time really defining what this is. So for us to try to tell you how to weight these, we wouldn't know ourselves.
We don't know.
We really don't know ourselves. We do it, and we do it fairly good. But if you ask somebody, how do you do that? I don't think most people really know how they do it.
Like pornography.
Yeah. You know when you see it.
Well, for some of us, maybe.
I've heard.
I'm glad I didn't say that.
She's quoting the Supreme Court, you know?
Right.
So
Or they
one
quote
last
me.
call for any more questions, issues before we start signatures.
The only comment I would like to make again, I think it's a great way to start up a handwriting database around the country. I think it's a really good tool for that. Most people have the system and start punching in data, and we share that huge database.
Is that the
Get some-
goal? Is that the goal?
Yeah, data I think is very, 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 very important. If we have data, we can learn from the data. Of course, we have to have means of learning from the data.
And then you
But
can
data
start
is
getting,
very, very begin.
yeah, then you can start assigning values to those
Yeah.
differences and similarities, just to give you. Because if you ask everyone in this room what is the value of a stroke going into the character, probably give you a different answer between 0 and 10. Because Pam didn't have any. He did.
Yeah, the one thing I would like to request all of you at the end of this workshop is to think about creating data sets that can be used by researchers. They're very hard to get hold of, and I think there will be a great value to us if you're able to do that for us. Ideally, you would have have them scanned, and we said 300 dots per inch.
Right.
Scanned, and here are the images that you can share with us, and of course with any kind of truth associated with it, saying this is the same writer, different writer, or if you have any kind of 9-point rating. I don't know if it's accepted generally, but any other kind of information you can give with it.
So I'm curious, I mean, do you foresee all of your research, I mean, that this is to be used for, you just said research, and Linton just said casework.
No, I didn't say
Or
casework.
okay, I'm sorry,
Yeah,
database around the nation.
I'm at the point where we
Okay.
create a database to do the research,
Okay.
to build the
Okay.
6.5 vision.
Yeah. Well, it's a continuing thing. So, as someone else pointed out, I think Emily was saying earlier on that every software system keeps on evolving.
Right.
Nothing stops at any given point, but it's usable at some point. Saying you can use it now, but we always have to think of what's coming next and in the future. So it's not one or the other. It can
I
be
think I
both,
started off
right?
at Photoshop 1.4 or something. So I'm a long ways from there.
Right? Yeah, if you look at the older program, you'd be saying, "Wow, that was so primitive compared to
It was extremely primitive. And this reminds me a lot of that,
Yeah.
when I first started using that and how much, just in the last 4 years, it's improved.
Oh yeah, definitely.
So would it help you for us to send you the Fox files, since that already has all the
That's what I was thinking.
Yeah,
the
what do you
data
guys think?
attached
One
to it?
file, maybe images would be the best, right?
Well, because then you might not know what the text is. Was my only concern.
Okay, well, that's right. If you want to give us ground truth associated with it, I guess Fox files would be good.
Yeah.
Yeah, that's what I was thinking. If we did this, if we did the processing and just send you the files, say here you go. That would be
Yeah, the original image
50
is,
examiners doing the work of
in
rather
Fox
2 or 3 people.
Would Fox files be better than TIFFs?
Yeah, Fox file is definitely going to have everything in the original plus extra. So
Okay.
unless that's more time for you.
Well, but I figure, if we are already making the Fox files in the course of our
Anyway.
casework anyway,
Sure.
then we could just burn those to a disk and mail it off to you, or however it's sent. Assuming our administration will allow.
That is a problem.
Is there a document examination swig or twig subcommittee that this would fit into?
Starting Sunday night, yeah.
Does SwigDog already have a computer algorithm side of things going, or are you now going to create it?
That's a good question.
Well, Carl, you want to add that to our long list of things to do? I mean, I'll bring it up. I had planned to take this and fill people in on what occurred here. I mean, our push has been to write standards and publish through ASTM. So we're at I think we're on our 18th, and we have 18 more sitting in the wings. And we're at that 5-year point with many of them where we have to go back and do the 5-year review. So that's where we're at.
There isn't enough here in all the software combined to really sit down and talk about standards yet. We don't have standards, we're not even using it, generally speaking. So it's way premature to even think about a SWIG.
Well, I've concurred or abstained from all my ASTM votes, by the way, on question document examination
Oh, thank
related
you,
materials.
Carl.
I just wanted, I stayed out of it.
Thank you.
So it's good at least the tool is getting there now, so these kinds of databases can be formed voluntarily
Well, we've
and ultimately lead to guidelines and standards.
Well, and I mean, one thing is, we're not allowed to state you should use this software or belong to this testing program or any of that. So we've written very generic language that says, you know, you can use software measurement grids, you know, and that way people can use Photoshop if they want to, but it's not a requirement in every case. They can use, you know, computer grids or glass grids or, yeah, whatever they want, so.
Some of the guidelines SWIGs come up with are useful for us who are developing software. Example is the 9-point scale. If SWIG doc recommends a 9-point scale, I think we saw that in one of the earlier.
It is already.
It's there, right?
Oh, it's a
the
standard.
ASTM standard.
It's an ASTM standard now.
So which is what we took, and apparently it's different standards in some other countries.
Yeah.
Some European countries use
different laboratories.
use a smaller scale, like 7-point scale.
Well, the way it's written, you don't have to use all 9.
Mm-hmm.
You can use any portion of the 9 too, because there's some labs that use 7, or some labs that actually use 5. Some do. So you're not required to use all 9. That's just a recommendation. All of these things are recommendations. None of them are rules. So and a lot of people don't like the 9-point scale. There was 2 years of solid 2 years of solid debate on getting to 9 as opposed to 7 and 5. You know. So.
But what's interesting is, last January at SWIGDoc, we had this big discussion because we had these Army lab guys in the room, and every one of them sat there and said, I hate the 9-point scale, I don't use it. You know, some of them had retired and gone to the Virginia lab system, and all of them were like, we don't use it, we use this language. And it turned out only like 3 of us in the room actually uses the language that's in the ASTM guide. So we suggested, and there was a ballot that went out this year or a survey, you know, what do you think? Is the field kind of turning away from the 9-point scale? Should we look at other language? Should we look at, you know, is everybody using 7 points or 5 points or what? And the feedback, Joe Parker's going to present it next week as feedback at SWIGDoc, but the feedback, from what I understand, was 90% of the people wanted to keep the 9-point scale. You know, so, but we had looked at the Australian scales, the European scales, the English versus the Netherlands versus, we gathered them all together and looked at the various language. So.
From the automated system point of view, we were thinking of modifying it such that you tell us what scale you want. 5, 7, fine. We'll change our result.
In reality, that's the way the standard's set up.
Yeah.
And that was a compromise. The 9 gives you all the options.
Yeah.
The way it's set up in there, but you're not required to use all 9. When I first joined the FBI, there was a 3-point scale. You either identified it, you eliminated it, or there was no conclusion. There were no other options. You didn't get any other options. So, and they've expanded considerably since then.
Okay, so why don't we start on the, it'll give us more time at the end tomorrow, so we'll start the signature model.
At least 3 or 4 of us are going to have to leave right after the break tomorrow too, to make our planes.
All right.
So.
Okay, so let's, we have some time, let's use it as best as we can. Okay.
Does anybody need a break? You have about an hour before you'd be leaving. Okay, no comfort break. No smoking break.
Ari, if we have time tomorrow, maybe we could have a discussion on how we would validate this in our labs before we actually start using it for casework.
Mm-hmm. Yeah, that'll be a discussion really.
Because that's going to have to happen.
Yeah, so we need your input on that.
tomorrow.
Now you have the software with you, and you can help formulate that. Signature matching. So I understand one of the most important functions of a question document examiner is signature verification. So that's a very important component of what you all do. And we have a signature verification module here. It's got some machine learning capability built into it. It's kind of interesting algorithms. Harish has worked on these algorithms. And we have the capability, and we'll demonstrate what it can do. By going through some of the theory behind it, you'll realize that this is far from the kind of things that you all do with signatures. We look at its performance and what will we do. This is a project we'll be pushing in the next 2 years, the signature part of it. The areas that we're going to be pushing are the signature part and also the 9-point scale we talked about, strength of evidence, some of those kinds of issues, and many of the other items that you have brought up here. So this is the kind of thing we'll be pushing towards. But this current system has this capability. It's got all these screens. I let Harish do the demonstration. He's much better doing that than I. So let me just give you the broad picture now. So these are some screens that come up where you can tell the system, I have all these genuine signatures here available. So these are all files. Every signature is a file. And you say, and you specify which file. There are all different file names here, original something. So these are, there are like 5 shown here. It shows 5 at a time, and it can be more. And I have all these genuines available. We call them genuines. And then there is a question signature over here. And the goal is to say whether the question signature belongs to the same class as all of these genuines. In the field of pattern recognition, sometimes people call it as a one-class problem. That is, does this belong to this class or not? That's the problem of signature verification. And the system is given this, and the system's output are shown over here. So there are 4 questioned signatures here. It doesn't have to be one question signature. There can be several question signatures. By clicking on any of them, that particular question signature shows up here as an image. So there are four file names. One of them is labeled as an original, and 3 of them are labeled as forgeries. Okay, I think the last one is also a forgery, right? So we created some samples. Here again, the data set becomes an issue. The reason I'm saying that this is in an earlier stage of work is our data set was all just created in our lab. We had, how many students? 20, 30 students contributed several original signatures, and then we had each other forge each other's signature. And we created a forgery set. And so that was our starting point. So we just have a set given to us by Lisa, which we're going to use, which are, I think, going to be much more useful, much more related to casework and so on. So this is what we had in our labs. So these are examples from there. And so we had all these files called forgeries, all these files called originals. And when these questions are presented here, the original comes out, this is an ideal scenario, and it worked here. So it is 97.7% with an original. So that belongs to this class. And all these forgeries came out as 4.66%, 4.06%, 4.06%. And what kind of forgeries were these? These were all, I don't know if you'd call them skilled or unskilled. These were, we presented each student saying, these are all the originals. And can you please forge these? So they try to copy it like that. That's what the students were asked to do. These are not skilled forgers. These are just people who have some drawing skills, I think. I forged them, I think. I also did some forgeries. I forged them using the famous, the amazing Randy. Has anyone heard of him? The amazing Randy. Have you met him?
I haven't met him.
He's a magician.
Yeah.
He lives in San Diego. Yeah, that's where all the magicians are.
Wizards, they call them.
Wizards. Actually, I was giving a handwriting, I've been doing handwriting related stuff for a long time. I was demonstrating at a postal forum how our handwritten address interpretation system would work. We used to have people come up to our booth and they would handwrite a signature, handwrite an address, their home address. And we would have a scanner and we would put that envelope on it and it would scan it and it would show on the screen, their zip+4 code. They didn't even know what the zip+4 code was. They used to put their 5-digit step, and because we had a database lookup and the whole thing, and we used to amaze everybody saying, the computer can do this. Read your handwriting and get your delivery point, put a barcode on the things, the sorting machines could work. So that was our demo. So the amazing Randy came by my booth because he was invited by the Postal Service to give some talk. He was kind of a free thinker. He came to my booth and we started talking about things, and he said, okay, I'll show you how to do very good forgeries. And so the way he did forgery was, so I signed my name and then he turned my signature upside down and he copied it like a drawing. So if you have it right side up and you try to forge, your natural way of doing the letters apparently drives it and it will not be a good forgery. If you treat it as a pure drawing, it comes out as a better forgery. So that was my method of forgery. Anyway, this is our data set here. And so this is the kind of results we get. So this, I guess these are two different screens. I don't know why I have two of them here. Genuine set. Is it the one and the same? I guess here I'm pointing out the scores for the question signatures. That's all. The two images are the same. When I was doing the slides, I guess I didn't realize that. So I will give you the theory behind it. It's kind of rather interesting. I think Harish developed most of this Kolmogorov theory for it, which is intriguing. Which is the task is I have got all these known signatures, and I have a question signature, and the computer program's job is to say whether it was signed by this same person. So how do we do this? Again, perhaps I can say no person signs the same way twice. Every one of the signatures is going to be different. And of course, we have this whole theory that every person probably has 2 or 3 different signatures that are quite different. When you're signing a legal document, you sign one way, check maybe another way. In the grocery store on your credit card slip, you'd sign yet another way. Or sometimes you'd sign with initials. So each person may have multiple signature types. What this current system does is it does not address that issue, that a person may have several different types of signatures. So, the future versions will have. The current system thinks there is only one way this person signs, and then goes about it with that assumption that there is only one type of signature this person has. So that's why we can run into trouble when we have multiple different types. So the way we go about it here is an interesting statistical concept which was developed, by us, where we have had these 4 signatures here and we have one question here. We convert this into a statistical problem, statistical distribution problem. What we do is we end up matching every pair of signatures first here among the nodes. So if there are 4 genuine signatures available, the number of ways of getting pairs is a combinatorial function called 4 choose 2. 4 choose 2, if you evaluate it, it's 6. So there are 6 different combinations, and you can count all of them. This is 1, this is 2, that's 3, that's 4, that's 5, that's 6. So if you have 10 signatures, that 10 choose 2, which is I think 45, is that right? Yeah, 10 choose 2 is 45. So it grows fast, the number of possible combinations of pairs. So what we accomplish here is, what is the internal variation of this person in doing the signature? So there are, in this small case, there are only six ways of comparison. So the computer can actually compute the differences between these signatures and create a distribution of these differences, which we can call as K to K, that is known to known distribution of the signatures. Now similarly, here is a questioned signature. So we can use this question and say, compare it with every one of the nodes. I don't know if you all go about it like that, but some version you must be doing, where we say, don't ignore any of the nodes and take this question and match against every one of them. Of course, in this case, you're only going to get 4 comparisons because there's only 4 of these. Whereas earlier on, you got six possible comparisons there, and you're getting 4 possible comparisons here. So now we can look at what are the differences between each of these. Call one of the distributions of these differences as a K to K distribution, and the other one is a Q to K distribution. So now the problem can be stated as, are these one and the same? Are these two distributions one and the same? In that this distribution, when you match against these, that variation is the kind of variation this person has anyhow. So that is how we state the problem of finding matching signatures. This is a mathematically stated problem, and it becomes a simple task of comparing distributions. So this is the same thing, expanded it out. For instance, these 6 comparisons can give us 6 values over here. One of them says 0.4, another 0.1, 0.2, 0.3, 0.2, 0.1. I believe these numbers have to lie between, no, they're not quite 0 to 1, is that right?
Yes.
0 to 1. So these lie between 0 and 1, all these values. So we need to have a minimum number. If you end up having, I only have 3 genuines, we'll say, look, your distribution is going to be terrible. You only have 3 possibilities. 4 gives you only 6. 5 gives you 10. We think that at least you need 5. I don't know what the community thinks about how many genuines you need. But we are saying from a statistical point of view, I think 5 is a minimum number we should have for having some kind of distribution.
For signatures, I always ask for 10 to 15.
You ask for 10 to 15, wow.
Yeah.
Okay.
For signatures.
Right. See, if you say at 10, you're going to get in a distribution 45 numbers, which is a reasonable number to have some probability distribution. 15 is luxury, right? 15 times 14 by 2, that's how much? 15 times 135, is that right? Something like that, yeah. So you can get that many data points. And this one gives you only 4 of these things. So this distribution is going to be a rather small question. Of course, if you had 15 up here, this will have 15 numbers, 15 comparisons. So the 15 comparisons here, and in your case, you'll have 135 values over here. So now we are asking the question, is this distribution the same as this distribution? And now we are getting into the domain of getting the statistician to tell us, how do you tell 2 distributions are one and the same? And a particular method that Harish checked out it's called the Kolmogorov-Smirnov test. It's a mathematical test to say whether 2 distributions are one and the same. Wow, it's one of those slides. Okay. I don't like those slides anymore. I might have had some time ago. Maybe you made it for me. Yeah. All right, so this gets into some of the nitty-gritty of what a Kolmogorov-Smirnov test is. If you don't like to get into the mathematical details of how do you do the testing, you can tune out now. All right. But the K to K distribution has these values, and the Q to K distribution has these values. And to do the Kolmogorov-Smirnov, you got to first sort these numbers in order like this, and you sort these numbers in order like this, and from that you compute what's called as the cumulative distribution function. And as you move along here, you ask how many samples values fell less than that. Is that right? Yeah, that's what you're doing. So we end up with the distribution going from 0 through 0.5. Is that right?
What?
It says 5.0 there. Should I have been?
No, the y-axis is CDF, so it goes to 1.
Yeah. All right. And the values actually are between 0.1 to 0.4.
So right. All values greater than is
should have been point there.
It's 0.5.
Yeah, should have been. So this should have been 0.5 over here, 5.0. So anyway, it'll look like this. So this particular CDF looks like this for this distribution. For this distribution, it looks like this. And so now the Kolmogorov-Smirnov says if you have these CDFs, I compute the maximum difference between the two CDFs and use a particular formula to convert it into a probability. So the maximum difference between these two PDFs, between these two CDFs, is 0.333 by looking at the two graphs there, and that will transform it into 89.98. This particular case, it's 89.98.
CDF is cumulative distribution
Function.
Yeah. So the smaller the difference, the better. The more likely it is a true signature, or the bigger the difference, the more likely it is
Okay,
a true
good question.
signature.
How do you answer that?
The smaller the difference, the greater the probability of similarity.
Yeah.
Say that again.
Smaller means higher likelihood. Yeah. Higher probability.
Of
match.
Truth
Of match.
or false.
Of truth.
Yeah. Right.
Thank you.
Okay.
The initial numbers you're having up there, 0 through 0.1, I guess, or 0 through 1. How are those attained? I mean, you're
that's the starting point. So when you have two signatures, the whole thing depends on when I give you two signatures, you got to have a method of saying how similar these two signatures are and state it in the terms of a number,
right?
Which is the fundamental similarity measurement question. I will get into that. What underlines? How do you come up with a number?
That's right.
Right? That's a similarity. It's called a similarity measure. Pattern recognition's most fundamental thing is how do you measure similarity of two things? I showed that in the earlier discussion when I give you two E's. The way we measure similarity is first map it into this huge number of bits over here, huge number of bits over here, and then we take the two bit strings and with a mathematical formula that matches bit by bit and compute some value, similarity function, and comes out with one number. I give you this bit string, I give you this bit string. These two differ by so many bits, for example. That's called a Hamming distance.
Mm-hmm.
There is other methods of doing that.
So in this particular case, the program is saying that there's a high probability it is not genuine?
It is genuine in this case, right?
Oh.
Yeah, it is genuine.
It is genuine.
Yeah.
Okay.
So if this number comes out to be small percentage, like 4%, then it is not likely to be the same right. So it's a scale of 0 to 100%. So the larger the number, it means there's a match.
Okay.
I don't want to use the word match anymore, right? You all don't use the word match, right? Yeah. Yeah, so don't use the word match at all in the courtroom.
That's different than what you answered before.
No, I'll just clarify that.
Yeah.
The difference between the two CDF, the smaller that is, the larger the probability will be.
Is DKS, is that difference?
Yes, that talks about the difference. That is mapped to a probability, which is a similarity measure. So this should be small, and that should correspond to that being larger.
Yeah, we keep alternating.
So
small.
0.2 would be very, very similar.
Yeah.
If it was 0.2, it would be very, very similar.
That would correspond to maybe a 95%.
Yeah.
So it goes between 0 and 1. Is that correct?
Yes.
Okay, I get to Jerry's question. So the root of all of this is to be able to compute the similarity between the two properly. And there isn't one simple way of doing it. We have one simple way of doing it, but that can be made better, which is what some of our future work could be. So this one is, again, fairly simple idea. It's very similar to what I talked about earlier on, bits in terms of the shape of something. So what we do is we take the signature and we superimpose on it a grid, which is typically of size, what is this, 8 by 4?
Yes.
Right, 8 by 4. We put a 8 by 4 grid. Signatures tend to be longer than higher, So we put an 8 by 4 on it, and we move the grid lines here, this 8 by 4, appropriately based on the distribution of the black values, where the ink is in the signature. So we look at it like that. Once we have a grid, we can map that into a feature vector that looks like this. which is roughly the same that we did earlier on, which was the I showed you the GSC, gradient structural concavity. The same idea applied here, not to a single letter, but to an entire signature. There we actually used a 4x4 grid, and here we're going to an 8x4 grid, and we come up with now this one is going to be 1024 bits. So the shape of a signature is characterized by 1024 bits as to what it looks like. And what does it capture here? What all these bits capture? They capture the fine variations, the stroke information, and then the bay and the lake information. It somehow represents all of that in this encoding. It gets it fairly quickly, actually. When you get a signature, it spews out a 1024 bit string.
So, but it's not just strictly a bitmap.
It's not a bitmap.
No, it's a string that has very significant purpose. Okay.
Exactly. The first part of it are gradient fine features. The second part of it are structural stroke features. The last part of it are the concavities or the topological information of the signature in terms of the layout of things and so on. It captures all of that. So unfortunately, this bit string, we cannot explain it to you in terms of, are we looking for the fact that there is a line over here, we cannot explain it in such cognitive terms here, other than saying roughly it captures the fine variations, the intermediate variations, and the topological variations. There is nothing specifically encoded here about these cognitive features. When I say cognitive, it means explainable things. I say I'm looking for this loop like this. I cannot say any of those kinds of things here. This is how it does. Once you have this, we are in business. If you are able to encode your signature into a set of numbers, then given two signatures, both of which are represented by some sets of numbers like this, I've got to say how similar is this pattern to another pattern of a signature, which is also the same length and size and so on, except the ones and zeros might be different places. And we use this particular formula. Given two bit strings, this formula says, given x is a bit string, this is x is a bit string, y is a bit string corresponding to another signature, and this is the similarity measure, where there are terms like S11, S00, S10, S01. All that they're saying is, to take the two bit patterns, if both patterns have a 1 in the same place, I call it an S11. How many S11 is how many bits have 1 in both places? That's an S11. How many bits have both zeros? That's say S00. 1 0 and then 0 1. That's all. You count, lay them one against the other and count how many of the bits match, and we compute this ratio. And this particular ratio has a name actually. It's called the correlation distance measure. There are like 25 different ways of matching two strings of ones and zeros. The simplest of them is called Hamming. Hamming simply says lay them one on top of the other, and wherever they differ, count it as one difference. If the two bit strings are identical, the difference or distance between the two is 0. If one bit is different, then they call it 1. 2 bits are different too, like that. That's called Hamming. This is a correlation, which is a slightly different method of doing this. And we worked with many different ways of measuring the differences and found correlation was the better one. And this is another one that Harish threw into the mix here. He found that the Kolmogorov-Smirnov method had certain advantages. Tell us that. In one way it was good, one way it was not good.
Yeah, the Kolmogorov-Smirnov test is very strict on forgeries, so it hardly misses stating a forgery as a forgery. Whereas this one is the opposite. If it's really genuine, then it will not miss it. So, it came out through experiments that we figured out this particular property of these two methods, and then the ideal one is to combine to take advantage of both methods.
Yeah. So this was another one, which is called the Kullback-Leibler. These are all standard things in statistical books. And so what we do is we take the two distributions and then we bin them. I don't know, this slide must have had all these things happening on it. Yeah. So we have the same old distribution. There are two different methods of manipulating numbers here.
No, sorry, what is KL again?
KL stands for the Kullback-Leibler. Kullback-Leibler numbers. Okay, Kullback. And Ler. It's a standard method of when you're given two distributions and you want to see how similar they are. Statisticians encounter this problem a lot. There are two stores, they're selling all these products. So many numbers of things they're selling in one shop and so many things they're selling in the other shop. The statistician asks the question, are these distributions similar? They're selling certain products much more and certain products, so on. So they frequently encounter. So there are many tests for measuring whether two distributions are one or the same. So one was Kolmogorov-Smirnov was a method. This is another method called Kullback-Leibler method. And this says you should bin these things into a certain number of bins. So 0 to 0.02 and 0.02 to 0.04 are two bins. Put all these numbers and how many of these fall in this bin, how many of these fall in this bin. You count those number of elements in that bin, divide by the total, gives you its so-called probability density function in this discrete space of two bins. Similarly for this, there are two bins here and gives you a probability density function along these two bins. So once we have that, we can compute from this the Kullback-Leibler distance, which says take those PDFs and do log of one probability over the other. This is 0.66 over here, this is 0.75 over here. Take that ratio times 0.66 plus 0.33, which is this number, times log of 0.33 over 0.25, that gives you 0.0072, and you get from that e to the power of this number gives you this number here, it's 99.28%. Very simple formula. You take your two distributions, bin them, and then use this particular formula, and e to the power of that number gives you, in some sense, the probability that the two distributions are the same. That's what it's telling you. And once we do that, so Harish conjectured that neither of them on their own is that good. That is Kolmogorov-Smirnov and Kullback-Leibler. And so he said, I'm going to take the average of the two, pKl plus pKs divided by 2. So there's one statistical method of computing the difference between two distributions, and another method of doing it. I take the average of the two. Okay, how good is this? Well, he did these experiments. What if I had 4 knowns and 7 knowns and 10 knowns going towards your 10 knowns and 15 knowns? And then he applied Kolmogorov-Smirnov method, and he found it. He was right 76% of the time here, 80% of the time here, 83% of the time here. So the accuracy of the system keeps growing as the number of known signatures keeps increasing. So you're learning more about the set. Similarly, the Kullback-Leibler went 75, 79, 84. All right, together they went 79. It's not just the average of these two, right? It's it's combined in the system. So it went 79, 81, 86. So he said, so these are all hard decisions, same or different, and you're saying we're getting it right 86% of the time, getting it wrong 13% of the time.
Yeah, the decision is made at 50%. So greater than 50% probability, we decide it as genuine. Less than 50%, we decide it as forgery. So there is, again, a hard decision made. If you want to find out the error rate of the system, then you can do it. But of course, we can also allow for reject. As before, between 40 and 60, no conclusions. We can do all these things also.
So we're making a hard decision and taking the toll of making errors, and we could have rejected between 40 and 60.
Yeah, the system, as in Cedar Fox, gives that number, and it doesn't actually say yes or no. This is, if you want to see how accurate the system is, this is just for our knowledge that this is how good the system is. what the system actually gives out is the final probability value. So it can be used to interpret. Okay, yeah.
And what do we have here? 100 minus FAR. This is terminology of biometrics. False acceptance rate and false reject rate. We're making hard decisions. So we can we have 100 minus FAR and 100 minus FRR, the two types of error. Roughly, I guess the components of this error rate is what it is. Okay. Yeah. User manual. All right, Harish. Let's go to your actual demonstration then. Do we have time? We have time.
Yeah. Again, you can follow along with.
Yeah, you can do the signature verification on your computer.
The sample images will have some signatures, so we will use that. And maybe tomorrow we can do the live scan on signatures. And so in the Cedar Fox main menu, you can close all documents if there's any open. There is this signatures menu here. So there is because we'll be seeing the first two of the options. First one is the enroll known. So where we give a particular writer, we associate these signatures with this person. That's the process of enrollment.
We are using the biometric terminology over here. I don't know if you call that as enrollment, in terms of saying getting the knowns together. So we call that as enrolling here.
Yeah. So we will first click on enroll known. You get this dialog box. You can give a name just to have identify that these signatures belong to this person. I'll just call it signature.
Call it NCS, today's name. National Center for National Center for Forensic Science.
NFSTC.
NFSTC. NFSTC.
I'm going to call it 1. This is the first writer I'm enrolling. So click on add files, and it will give up this. You can select PNG images.
Don't select document images.
Oh yeah,
signature folder.
First, you can go into this folder called signatures. I guess all of you must have the signature folder. You can get into the signatures folder, and then select PNG. And we have samples of both original and as well as forgeries, so we will test out both. You can actually choose to, let's just choose this one. We have to select multiple samples for enrollment. So you can click on 10 original 10_1, and then all the way press shift and press original 10_4.
You can select more than 4.
Okay, I'll select one more. Select 5. I will leave one for the question. There are 6 original samples of this particular writer, but we will leave one for for the testing scenario to see if it is really genuine. So we'll choose 1 through 5.
So we only have 6 originals per person, unfortunately, in our data set. Yeah.
So you can click on open. So we have all these things here, and then click on finished. It will take a couple of seconds, and you should get this dialog box that says.
Go to 1 and press shift key. Go to 5.
Everyone gets a message.
Yep.
Okay. Again, I'll repeat. Go to signatures. Type in. Go to enroll known. Give a writer name. Click on add files. So all this is from the signature menu. It's not from the Q or K menu, because the Q and K allow you to select just one document. If you want to select multiple, this is all signatures. So this is all from this menu here, signatures. Okay, so you can once you should get this information, writer information saved. So what it has done so far? It has taken these 5 signatures and has compared every pair in 5. So there were 10 comparisons made, and the distribution is what is getting saved in this file. So this distribution is saved in the particular file, NFSTC1. Yeah.
Is there a way to see what that distribution is amongst the intercomparison of the Ks?
Currently we don't have that. The images will come up when we test against the enrolled. We can see all the images. The distribution is, we can have definitely an option to
because sometimes we're given in our knowns. Sometimes we get a known from somebody else that's alleged to be from this person. So sometimes the knowns that we get aren't actually knowns from the person they're supposed to be.
Okay.
So this might be a way to see that.
Sure.
To say, you know what, this one falls way outside the range of the other ones.
Yeah, that is something again kind of comes under the category of what if all the samples in this set are not already similar. So again, probably the next version of the software will already find it out, saying there are 2 different kinds or 3 different kinds in this. Please enroll them separately, because this current mechanism will it assumes that everything is like one bunch.
Right.
It's very important. It's very sensitive to that also. If you have one outlier inside, out of 5, one outlier, it contributes 4 values itself with the other 4. So there's 5 of them here is one outlier here. To the distribution itself, it contributes 4 values. That's a lot of noise coming inside to the distribution. So it is very sensitive to that. So that's why it's important that we definitely give genuine samples inside. Yeah. But the next version we'll try to find out if there is some noise in it. So once you have this, you can click on OK and go back to signatures menu, and there is a second option. It says test against enrolled. You can click on that, and you must get this box. So the first thing you can select writer, which is the top right, and go into signatures folder, and you should have the file that you just named, NFSCC. Click on open, and it has come here on the top right box. You can click on that name, and it must display all the images of that writer. So we have 1, 2, 3, 4, 5 of them enrolled. Yeah, we could have an option to display somewhere here the distribution. Yeah. So if you now have these 5 enrolled, then there's a button on the left which says select question. You can click on that. Again, choose PNG. Then we will select multiple question here. We will maybe select 1 genuine and some forgeries. To select files on different places, you can use the control key. So you can just select one. Let's say this one, original 10.6, and then press on to the control key and select the others. There are some forgeries here at the beginning. Forgeries 10_1, forgeries 10_9, forgeries 10_20. So we've selected 1 genuine and 3 forgeries.
Okay, before you proceed, is everyone keeping up? Yeah. Okay.
Just select one and press Control and press the keep pressing Control and select the rest. And then click on Open. So they've all come up here. To see how they look like, you can double click on this list. Let's say you want to take a look at how this original looks like. Just double click, and that file should come up here. To see how the others might look like, again, you can just click on that particular image.
Yeah.
So you have these, so if you want to test these questions, each one against this set of enrolled nodes. And you can click on Start Testing, and it should test and actually sort them by probability of match.
Why don't you run through each of those images now that we know its opinion?
So this one got 98.44% similarity with this set. All the others, which is this one, got 4 point. All the rest got 4.
Yeah, let's look at the images because that's helpful.
This one,
yeah,
the image,
next one.
and this image, and then this one.
Question for you: would you call these as skilled forgeries or unskilled? These are like students copying each other's signatures. Unskilled.
Unskilled.
Unskilled. Okay.
Yeah, we can try some skill maybe on live scan tomorrow. Also, the current system does not take into account any disguise. For example, if these are all enrolled signatures and the question comes in which is a disguised signature, well, ideally, I think you want the system to tell it is disguised, but the system will go and say, currently it will say it's forgery. It doesn't match these. Of course, the extent of disguise is also, if it's already too similar to the genuine, then it will say genuine. But if there is a mismatch, so it will have a very low probability of match. So the current system handles genuines and forgeries alone. Doesn't handle disguises. That's something we will look at the next set of things we will do. There are other options here. We don't have samples, but generally it's useful because there's this option of remove printed text. And most of signature samples come along on checks and things like that, where there is some interfering printed text material option. So you can have this option checked while doing the testing.
We have some samples.
Do you have an example?
Yeah, I think I have some.
Enroll. I'll just do this here and see if. This one?
Yeah, those from the.
Only 2.
Okay.
Yeah, we don't have enough samples for enrollment actually. Yeah.
But for noise removal?
Yeah, we have to enroll them first, so it will not accept if you don't. If you have less than 4, it will not even accept the enrollment. 5 is good to have. 4 is theoretically correct to have. The distribution will not. It won't let you have less than 4. 4 is minimum, but at least 5 is where the accuracy of the system at least comes a little reasonable. 4 is you have at least only about 60 or 65% if you have just 4. Yeah. Again, the place we lack a lot of data in this set. I guess we have more and more data. We can do much more here. The current system accuracy with 10 enrolled is about 86%, which we saw. That's again average of both kinds of accuracy. Times when we say a truly genuine as forgery and the other way around. It's average of both kinds of errors or accuracy. Yeah.
Have you tested this with tracings?
No. But I can. The current system, I can say that if you keep it on top and actually trace, as long as there is smoothness in it, it will give it as genuine.
I was just thinking because usually you don't get that smoothness. You usually get some tremors, because you're going so slow. I'm just wondering how sensitive it is to picking up that tremor.
It will be sensitive because what the gradient feature actually goes along the contour and tries to obtain how oriented the next pixel with respect to the previous pixel. If there is a lot of movement in there, that definitely will be captured. So if in that sense, it will not favor the genuine case. Yeah. But if it is smooth, then it's going to be. Yeah.
Do you have to use original signatures when you scan? Can you use copies?
You can use copies like, you can use copies, yeah, sure.
Photocopies. Does that affect the accuracy?
As long as the image shape remains the same, it should not affect. Yeah, because the features are computed based on the shape of the signature, the pattern, so that's not affected. The features will not get affected.
It is not using the pressure, like the fine grayscale variations that you visually would observe. It is blind to that one. It's just saying, okay, this is a stroke. It captures that much. If you're seeing fine variations in grayscale, it is going to miss that part there. So it gets thresholded into pure binary image.
I was just thinking if you had the genuine signature, photoshopped it, skewed a little bit, and then put it in, how would that match up?
Even if you get a third or fourth generation photocopy, it can skew it so badly. I don't think. I think it causes a lot of trouble.
Of course, the algorithm is invariant to scale. So if it's suddenly written very big and small, it's invariant to that.
Would that be linear scale? Because a lot of times the machines don't scale it linearly.
It's invariant to linear scale.
Okay, so but if it
scales
it and skews it at the same time.
Because we fit a box around it and
so
put a variable size grid.
A large signature or a small signature, we just put a box around it. And we only get 1024 bits out of it. So it doesn't matter if it is just a magnified signature. But if in the magnification process you had some distortions in it, of course, it will be different then.
So if it magnifies it only laterally but not vertically?
Both ways.
Both ways it's invariant to linear magnification. If there is some non-linear distortion, then it will be affected, yes. You can do some live scan.
Harish, could you give us the formula for is it?
Similarity?
No, when you said if you have 4 signatures, that's equivalent to 6 comparisons.
4 choose 2?
What's it called? 4 choose 2?
4 choose 2. It's written as 4C2, that's mathematical notation.
It's 4 factorial by 4 factorial by 4 minus 2 factorial. So
how many ways can you choose 2 given 4?
So choose 2.
That's what 4 choose 2 is. So given 4 signatures, I can. How many ways can you get pairs of signatures? And that's 4 choose 2 is 6.
I might actually have one more sample which I have already enrolled before. I think this was sent to us. Take a look at this. I think these were the images that Lisa had given. Yeah. So again, this particular set did not have forgeries, but it had disguise and unaccustomed hand. As I said, it does not currently process it, but we will see what it performs. So I previously enrolled these 4 signatures, and I'll select some question. I'll select the. I think I've enrolled 4. The 5th one, genuine, I will select it, and I will select the 2 disguised versions and the 2 unaccustomed versions. And I'll test it. I suppose, yeah, all of them were pretty poor here. The original also had only a 17.37. I suppose one of the main concern in this is the line that's going underneath. This was all taken out of checks. So one processing that can be done is you can open this image as Q or K and perform the line removal, and then we can try enrolling it.
Yeah, because that might be overwhelming. That says, look at this nice pattern that occurs in.
But these were even lower, yeah.
But shouldn't that give it a high probability of being the same?
Yeah.
With the,
Yeah. Well, I'm just speculating there.
yeah.
Well, really, with signatures, this is what the bottom line is 95% of the time, you know. Did he write it, or did someone else write it? Is it disguised, or is it
No, he disguised his own.
forgery? Oh, I'm saying,
On these, yeah.
yeah.
Okay.
What is?
Yeah, we have never worked with disguised signatures
Yeah.
before. You know, Lisa has just given us this data set, which is what our plan of action in the future will be. So you saw that was a simple data set, and we were kind of amazing ourselves that we are able to do 86, 87% of the time using a fairly straightforward method. So that's a baseline.
Yeah.
And we need to subject it to a lot more data. And the only data we had, as I said, was done by our students. Now we have Lisa's set, and she's promising to give us more. And you have the system with you also. You can also play with it and see for yourself what's happening, or if you send us the images. So and so we have to develop algorithms to handle these things. Our basic feature set may not be enough to handle these.
Yeah, these were how the originals look like. So what I did was I used the region of interest to actually make out those individual signatures. So if you have them on checks, you can click. You open them as Q or K, doesn't matter. Just open the document, which is scanned like this, and you can choose the define ROI, and you can just crop it out like this. And that's how you define. This is how I define the other signatures.
Let's do an underline removal on it and let's see what happens.
Okay, let me define the others. Oh.
We are in uncharted territory here.
I would need at least one more, so I just opened another file. I just had 3 in that. I think this has 2 more.
Do the signatures all have to be saved in the same format for this?
Uh,
Do you have to
TIFF.
do all TIFFs or all
Yeah.
video?
TIFF or PNG is accepted.
Oh, they all have to be the same format.
They all have
I
to
guess
be the
it's,
same.
yeah, when it opens, it converts it to Fox file. So I
It's
guess,
going to do whatever. Okay.
yeah, so it can read both TIFF and PNG. So
Okay.
either is fine.
So I've saved 6 of them here, and I can open them and try to process them. Tools, I'll go to remove underline,
Simple remove underline worked reasonably well.
and I'll save it as image. I'll do this for each document.
Why is he choosing TIFF this time instead of PNG?
I saved the ROIs as TIFF.
Ah.
Yeah.
Because you'll expect
You have to
better
save it
pins.
as TIFF. After all,
No, you can choose
you
PNG
can
or
choose either.
Yeah.
All right.
Oh, I missed that.
If you're scanning in a document that's been previously copied or scanned and it was not scanned, it's skewed. When you're scanning it in, you need to try to straighten it. I mean, will the fact it's skewed, that will make a difference, won't it, if, in this process as far as evaluating the slant or?
Yeah. well, the system has a skew correction option if you want it. Again, if you can open the queue and then under tools, image enhancement, there is skew correction. So you could, I can show that. Just open a document here for signature. There's under tools, image enhancement, there is skew correction. So you could use this to correct.
You can apply it to the entire document, right?
It will apply to entire signature, yeah.
Oh, this is only for signature.
We could use it for any document also.
Document also.
Yeah. So I'll try enrolling it again.
And is that an automatic correction, or can you determine what the correction is?
Currently, it's automatic.
You can, there's a really easy way to correct skew, even if you just throw it in there. Just use the measure tool.
So if
draw
it
your
is
line,
very skewed,
and then
you know, it might not do it.
That's probably the easiest way to do it. And then save that.
5.
Oh, I just had 5. Okay.
Yeah.
So I'll just select. Oh, I missed the 3. Okay. I'll use it for. So again, we'll test against enrolled. I think I left 3. Okay.
Yeah, use 3 as a question.
For some reason it doesn't say the name here. And this one,
Nice.
81%. So the line did make a difference.
Big difference.
Yeah, huge.
I don't know the answer any more than you do. Why that?
You would think it would make it more.
Yeah, I would have
genuine
thought that
if
line would have
less.
dominated it, that it would, all of them would look the same.
Yeah.
Yeah.
And these are all.
Well, maybe, you know, the base and all that at the bottom are openings are all shown now, which remove the line made it.
Yeah, definitely the line will cause some interference in the calculation, as I'm saying. If it was here, for example, the concavity feature will be absent. It may be that the other line had a small break, things like that. So it will cause some. And also because in the variable size grid that we are imposing on the box, the grid is based on the density of the pixels. Where there is more dense pixel, there is more grid. There is finer grid placements. So a line that's going through might interfere with where the grid is placed. So.
And Lisa, these are all the same author, so it's an accurate author assignment, but he's trying to mask his signature in some way.
Right. One he just tried to disguise, and the other one was offhand or unaccustomed hand.
What does offhand mean? I'm afraid
If he's
I'm gonna
right
find out.
hand, then
Oh.
he used his left hand. If
Wow.
he's left hand.
Thank you.
Yeah, that's where it is. So, and of course, if this the number of times it gets it correct will increase if you have more nodes enrolled. Of course, and it reaches saturation at some point because 15 and 20 may not make a difference because all the variation that were to be captured in this 15 is already there, and 20 is only going to be redundant. But it's not going to worsen it, but it might just be there.
But if you have a writer with a big range of variation, you might need all 20 of those to capture.
Yeah, as Harish pointed out, if a person has a big range, the system is going to allow for all kinds of variations. So it will accept all kinds of things as, okay, it falls within that wide range this person has. So in a sense, this performance deteriorates when if a person has multiple types of signatures be subjected to this system like this. Of
We
course,
have the
another
same problem.
It's a problem.
Like
The other
same.
possibility is you could cluster them yourself and say this is NFSTC 1A, NFSTC 1B, NFSTC 1C. Call them as 3 different signature types. And then maybe it will go into one of these classes properly without degrading the total performance in the system.
Well, and we might get, like you were saying earlier, we might get more formal signatures and more casual signatures, and then we could just separate those ourselves.
Right.
And work those as separate groups.
Right. Of course, another possibility is we could have the system do it for you. And if you say, I don't want to do it, you tell me how many clusters are there. That's conceivable because we know how to calculate the features, and we can cluster them for you. It's I'm discovering these. So that's what we're thinking of our future work. So
The current system does allow you to enroll them separately if you know the different types. And in select writer, you can select both the types. For example, the first one we enrolled with the rule lines, and second one was something like this. Suppose it had, but not able to select multiple here. I guess that was, in identification. Yeah.
Right.
So this is signature identification is where you actually have the third option here, where you can select.
Yeah, I can show that also. Whose signature is this? You know, that's the kind of question, signature identification.
Yeah, I think this has not been updated. Doesn't let me select multiple files, multiple signatures. I guess it needs to fix.
You are not able to do signature identification? Oh.
The option is you can select multiple writers here, and then the question signature is matched against all the enrolled samples of each the writer, and then it brings up the writer on top. For some reason, the selection option is disabled here for me to select multiple types, multiple files.
What about signature retrieval?
Retrieval is you select one. Yeah, retrieval is when you select. It's like image word spotting. You just select one signature. You select a bunch of signatures. It's just one-on-one comparison. So retrieve the one that's closest to this. So it's a direct. That's more for when you have a lot of each of your signatures written by different people, and you want to pull out the document which was signed by this person. So it's that kind of an application. So there is no forgery and things like that over here. Everything is genuine. You just want to pull the one that matches this. So
yeah, we have a code for this. We have not put it fully into the system. Certain applications, such as legal applications, you have all of these office documents signed by various people in this company, and we need to pull out all the letters signed by a certain person for some legal issue. So we provide that as a query, and it tells you which documents have that signature. Basically, it's the same matching method, but it needs to have a way of finding the signature inside the document and pulling them out. So it's just a matter of putting the code in properly.
So I can show this again. So what I did was I just selected this one as the query. I selected 3 different images, and I asked it to retrieve the one that is closest to this. So it just puts up this one as top choice. This is the retrieval one. Yeah.
There's one with some noise there. Maybe you can demonstrate that part. Or?
Actually,
Okay, you can
this
select
one?
Yeah.
I could select that one as the query.
Yeah.
Yeah. Signature retrieval. PNG in the signatures folder. And just select this one as the query. Do we have another signature of this person?
Probably not.
Maybe this. I don't know. I don't think. None of them is having a small. This distance tells you how close it is to the original signature. About 0.2, 0.3 is what you will get when it is really the same, and you get a larger distance when not the same. I think it's about it. We can show some light scan of signatures.
Maybe you can do that tomorrow morning. Yeah.
Can you go back to the test window, please? We have the printed text box there. Is it possible to put a box there to remove the line as well?
Sure.
Well, that's going to be a pretty common feature. Line.
Okay, there's a small catch there. the enrollment has already been done. Okay. By the time it comes here, this is only the testing option. Gotcha. Okay. So it would be fine to have some kind of a box here, while enrolling.
To remove the line.
To remove the lines.
Okay.
Yeah.
Okay.
Yes, that's possible. Yeah.
Yeah, we found in all these office documents we have looked at, there is going to be a lot of interfering printed matter, whose name it is, or on a check. So these are important functions to have. We have that code, some of it is here and not all of it is here yet. So if you have pristine, nice, clean signatures, of course you could say, I can use the system now by, I will do that work manually by somehow cleaning it up and then give it to you. If you're able to do that, we can use it. But if you want that to be done automatically too, you have to use some of our code. But it's not going to be perfect. So there's a printed A touching the bottom of this handwritten A. It's hard to remove it as which one is the handwriting and which is the print.
Again, there is more manual intervention there. You can use an eraser to erase it off. That's the first thing that will be there in the next version. Yeah.
So we have covered the demonstration aspects fully, except maybe some more cases we could do. Pam had given us an example, which we can do tomorrow, since I think we're almost close to 5. That's one thing we can do. And then we can have reiterate any of the things we did, and also have some free discussion about issues, legal issues that Carl has wanted me to cover. To whatever extent I can, I will try and do that. I think you will all be more knowledgeable on those issues, and so we'll have a free-form discussion on that. Yeah.
Do you have a target date for version 1.2?
1.2 is going to come out very soon. The database function MySQL was ready. I told Chen not to put it in because, if there are some small, we have tested it fully. And I didn't want it to come and crash over here, and all of you will again not believe us. So I didn't want him to put that in. Same thing with the eraser tool. It is ready, not fully tested. We haven't put that in. So, right, those are the two things. Immediately you're going to be doing it.
And a few of the small fixes that we saw, we weren't able to select multiple things. Those will be
the small things. So 1.2 should be out in another few weeks. Because we have it ready, we just haven't put it in. And 1.3 is going to be further down, which will have bigger things like overlapping line segmentation. So if you have things coming down here and going up here, we'll have a cleverer way of separating it. Right now, it just goes brute force and things all get joined up and so on. So that's what's happening, right? That's one major thing. And 1.3 may have the whole basic idea of independence of features. See, right now we are using Adam Osborne's idea of multiply the probabilities in the writer verification. It is a good first cut approximation, but if you want to push it, it's always like this. You can get 80% performance or 90% performance rather quickly using simple ideas. But if you want to go from 90 to 93, you got to have much more sophisticated models. And so we're thinking of putting that one in terms of allowing for dependencies. I showed you one graph there of 12 features, how some of them were correlated. When features are correlated, if you assume independence of features, you're not going to be as correct all the time. So if you want to improve better, you got to take into account that correlation, which is something 1.3. That's going to be maybe 3 to 6 months from now. But 1.2 should be out quickly.
There is also in 1.3, we might also have the clustering of the signatures automatically to identify multiple types. So that might also be 1.3.
Yeah, as I said, this is going to go on for a couple of years, and I'm just keeping my fingers crossed. It's still in the process. We haven't got final approvals on it yet, but indications are good at this point. So our focus will be more on this. And the signature front is what seems to be the demand from the community. We had a small meeting in Washington, D.C. Linton Mohammed was there, and Lisa was there, and a few other people. Jerry was there. And some of the message we got was signatures are important. Can you do more in this area? So that's one thing we're going to be doing, as well as the strength of evidence things seem to be attractive, and so how we can do that. We aren't doing that on the signature side right now. Signature side just gives a number. We're not giving it strength of evidence like the writer verification side. So that's where we want all your inputs and feedback and so on. So that's the price you pay for, coming to this workshop to give us your feedback offline. It doesn't have to be here.